let's start from the very beginning, what the root server systems are. So to understand what the root server system is, let's also understand a little bit about DNS. So whenever you maybe send a query such as facebook.com, or even let's just call it wechat.com, or even any site that has maybe a top level domain that ends maybe in, for example, in .za, .coffee, the first point of contact is the root. The root is it sits at the very top of the DNS hierarchy. It is actually indicated by this dot that you see there. From the root, the top level domains are delegated. So delegation means is that from IANA, which is actually a function managed by ICANN, you have organizations, companies, and even some of them owned by government. Others are owned by commercial interests and other stakeholders who actually manage one of the top letters there. And for those who've been in ICANN, I think this is something that you're quite familiar with, those who are in the ICANN community. So the root zone sits at the very top, and from there you actually are able to reach to all the other domains because that's where the resolution starts. Now, the root server, on the other hand, is the machine, or can I say the physical servers that are actually deployed to serve the root zone and make it accessible to the global audience that uses the DNS. DNS is actually a very critical part of the internet, and it forms a very essential part of the technical underpinning of today's internet. And without the DNS, basically would not even be able to get to any of the sites that you like to go to, because unless you can master how IP addresses are. So the DNS helps to map now domain names to IP addresses, and even conversely IP addresses to domain names. And the root zone is served by just this particular special purpose machines known as the root servers. So currently, most people think that there are 13 physical servers, but that's not the case. There are actually 13 labels. So 13 labels are just the letters A, B, C, D, E, F, G, H, I, J, K, L, M, from A to M. And each of these labels have an assigned IPv4 and an IPv6 address. I'll talk to you more about the 13 labels and also the organizations that manage them, and how actually there are thousands of instances and not maybe just only 13 servers in subsequent slides. Okay, so I will give just a brief overview of what happens in ICANN and how the changes are made to the root zone, and how they end up at the root server. So basically, there's a policy development processes happen in different stakeholder communities within ICANN. So for example, governments are represented through the GAC, the Government Advisory Committee. Then there's the GNSO that deals with commercial and non-commercial interests. Then there are all these communities will maybe make a request to for a change, perhaps maybe to delegate a given top level domain, or to maybe include a new string on the top level domain. So once all that happens, so there's a change request that is now brought about to ICANN through the INR functions. And through IANA actually works hand in hand with the root zone maintainer. The root zone maintainer is a separate party, and currently the root zone maintainer is VeriSign. So once the changes are received by IANA, then the root zone maintainer then publishes those changes on the root zone. The root zone now is just only a file. You can even download it on IANA. I will actually share the link of the root zone for you. You can actually have a look at the root zone file. It's actually a text file with all the top level domains and even the DNSSEC signatures, and that is published by the root zone maintainer. On publishing the root zone maintainer, it is distributed to the operators that maintain the root servers. So there are 13 labels, but then there are 12 operators. So each of those operators gets an exact copy of the root zone without it being altered. It should never be altered actually. And once they receive that copy of the root zone, they now distribute it to their infrastructure, which are the root servers, and the root servers are then able to actually answer all the queries and responses that you get from different resolvers from that that manage queries from different end users across the world. And that's basically the process in which now you get from a top level domain or changes to the root zone all the way down to how they're distributed to the root servers. Okay, so I'm going to talk a bit on the history on how we actually got to where we are, how we ended up with 13. And to begin with, let's go back 37 years ago. So in the year 1983, the internet then was an experiment. It had not actually become public. It was then known as the Advanced Research Project Agency Network, ARPANET. During that time, it was basically, I'll say it was a network for geeks, and it was actually meant to serve and distribute, let's just call it, it was distributed, yes, but it was also very limited. It was mainly in the United States. But during that time, there were two computer scientists, Paul Mokapertis and Jonathan Postel. They actually defined what DNS is. Before then, there was no DNS. DNS did not even exist. What existed was instead what you call a file called hosts.txt. And in that file, you had maybe the name of the machine, a host name, and the IP address. And each and every person had to keep a copy of the host.txt. So this method was not very, can I say, intuitive. It had very many overheads. And therefore, Jonathan and Paul, they decided to actually come up with the DNS, the standard itself. But it was not actually documented or standardized until 1987. But this is where DNS was actually first defined. The following year, in order to actually test DNS, Jonathan installed the first root server in the University of Southern California in the Information Science Institute. So he actually deployed the first root server in 1984 to actually serve the root zone and to also test the new DNS software. In 1985, the number of servers had increased to 4, and 2 were in the US East Coast. So at this time, the US military was actually running a separate network called Milnet, and they also wanted to have a copy of a root server. So one of those was deployed in the US military. In 1987, a few things happened. First and foremost, ARPANET actually was opened up to the academic and, can I say, research networks. And this was actually undertaken by the National Science Foundation, and they created their own backbone called the NSFNet. So with the opening of the ARPANET to the National Science Foundation network, certain academic institutions started to join. One of those was the University of Maryland, where actually a root server was deployed. The other ones were actually the Stanford Research Institute and RPI. And of course, the US Air Force and NASA also had their own instances of the root servers. So by then, there were 7 root servers that were now in deployment by 1987. In 1991, the internet actually started going global. And with this also the root server system started to first have its instance outside the United States in Sweden actually. So it was in Sweden because at that time there was a research network called NordUnet that was actually geared towards academia. Today, you'll still find that one of the operators that has a label of the root server is actually NetNode that is in Sweden. So, but it goes back a bit early in 1991 when first and foremost the first root server was deployed outside the United States in the Scandinavian country. By 1993, the number had grown, and by this time, the ARPANET had ceased becoming now a research project. It was now the internet started to becoming commercial, and as it became more commercial, even non-academia and also can I say, military institutions started to also operate their own root servers. The first one was Internic, and the other one was the Internet Systems Consortium. IC is actually known for making the popular implementation of DNS that's used all over the world. It's called Bind, and they started operating the root server instance in 1993. However, before 1995, you did not have actual labels. You had now just like if you were hosting a root server, it was called as milnet.rootserver. So in 1995, Paul Vixie started to work on, Paul Vixie is the founder of ISC. And right now he's working with Farsight Security, which is a company he founded. But he started then to actually standardize the naming convention of the root servers. So first and foremost, each root server will be actually given a label starting from the letter A. And each root server will be reachable by a domain name known as root-servers.net. And this is a time that there were certain technical limits that were actually being reached because that's, and this technical limit is what actually is responsible for having the 13 labels. So I will say that this limit was actually being reached around 1995. At the same time, you find that the naming convention was becoming standardized. So this brings me to the next point. By 1997, the technical limit had already been reached in the DNS, that is on the protocol itself, on how many actually servers could be reasonably packed in one packet. So by then, 13 was the maximum number of, can I say, addresses, IP addresses that could fit in one DNS query packet without it actually being fragmented. Hence, once this limit was reached, also the total number of servers had reached its peak. So, and that's why today there are 13 labels, and each label has an IP address and hence the name of 13 root servers. So this is the current status we have. The current labeling and also infrastructure is built on 13 unique root servers that are still in deployment up to today. Okay then, so to just only jog your mind and to also help make this presentation a bit interactive, I would kindly like you to answer a quiz question. And the question is, when was the last time you used DNS? And I would request that you go to the website www.menti.com and type the code 7341713, and I will wait for your responses.
Menti.com and use the code 7341713. When was the last time you used DNS? Was it a few hours ago? Are you using it now? A few days ago? Or you've never used DNS? So, Paul, as we receive the responses, anything interesting to comment about in this question?
So, okay, so Okay, so I'll just say that the DNS is ubiquitous, and if it wasn't for the DNS, you'll not even be able to access this Zoom webinar right now. So I may have given away the answer. So no worries, but generally we have actually come to rely on the DNS on its own, and without it, most of what we're doing today would not be possible. Online, that is online. Our online experience will not be, will be very different. Perhaps it will be more or less like what happened in the days of pre-DNS in ARPANET, where you actually query using IP addresses, and you'll have to memorize IP addresses for different services, which is not really fun.
So basically, we expect to see more responses, and this is what we're seeing, right? We're using DNS right now. So Paul, over back to you.
Thank you. Okay. Okay. In my next part of the presentation, I will discuss about the root server system today, its global distribution, and also in particular its distribution in Africa. Okay, so today, as I've maybe mentioned, that there are 13 labels, not 13 physical root servers. However, because of a technology known as Anycast, you're able to actually deploy multiple instances associated with one label. So let me give an example. So I mentioned that each server has its own unique IPv4 and IPv6 address. Okay, but how do you get one machine to actually be distributed everywhere? And it shares just the same IP address. So what happened is that in the ITF, they defined a technology or a protocol known as Anycast. Anycast allows you to actually deploy one machine with one singular IP address and distribute it across the entire region, across an entire place. So each of those machines or instances that are deployed will share that single IP address. So with this, we've been able to go actually to this, it's been updated to over 1,300 instances of the root servers that are deployed globally. Okay, also I've mentioned that currently there are 12 root server operators that maintain these labels. I will show you their names and I'll list them. And one statistic was done that on 1st of December 2018, there were 77.7 billion queries received by the root zone servers, and alone in just that month alone in December. So here is very interesting. Um, the root servers actually do receive queries, but they receive them through resolvers, and the resolvers are now the machines that are operated by your ISP. So those machines, so when you're sending a DNS query, it goes to the nearest resolver, which is either the one operated by ISP or the ones that are uniquely known like Google's 8.8.8 or Packet Clearinghouse 9.9.9. All of these machines receive user queries from your devices, your laptops, your tablets, your phones, and then they take these queries to the root servers, to the nearest instance of the root servers. So I will mention this a bit slightly in detail. Okay, so I'll start first and foremost with the root server operators. So currently, each of those root server operators, there are 12 of them, and each of them actually all of them handle a label. However, VeriSign, which handles the labels A, also manages the label J. The other root server operators are the University of Southern California, Cogent Systems, which is a commercial entity. Then there's the University of Maryland. NASA still maintains a label. The Internet System Consortium, which has maintained a label since 91. The United States Department of Defense and the US Army Research Labs, which have maintained it since the days the internet was then part of the military research under ARPANET. NetNode, which is based in Sweden, have actually transitioned from NodeUnet to actually maintain the I label. In Europe, you have the RIPE NCC, which is equivalent to AFRINIC, but they now serve the European region. ICANN maintains the L label, and Bob will talk more about that. And WIDE is actually an academic project in Japan. So some of you may ask, how come maybe maybe certain countries in Africa, or even there's no label maybe from Africa. And when this question is raised, we actually point on the historical reasons of when the internet was made, or it was deployed first. It was deployed in mainly US institutions, and therefore the current distribution of the labels is based on that historical context, that it was first deployed in the United States, and as slowly as it went around, and until the limit up to 1995, most of the institutions that were managing the internet then were based in the US, a few in Europe, and Japan came in a bit later. So that's why, basically, this is why it's skewed, or can I say it is more skewed towards US and also US institutions primarily. Okay, so let's have a look at the root service system in the continent. So I was asked a question earlier on how many root server instances there are globally today. So there are actually 1,326 instances as of today. And all of this are deployed by the various organizations, all the letters that are mentioned. If we zoom into Africa, I will actually mention that these are statistics. And so on September 2020, there were 9 root server instances in North Africa. In Western Central Africa, there are a total of 24. In Eastern Africa, there are 28. And in Southern Africa, there are 50. So I'll just show you just a few of the distribution using the maps. So this is in Western Central Africa. There's quite a number in Senegal, which has 6. Liberia, Cote d'Ivoire, Burkina Faso, Benin. Then you have Gabon, and also in DRC, you have distribution of various root servers. So the other one is in Eastern Africa. So I like to mention that the 14 is a bit confusing. If you zoom in, you'll find that they're distributed both in Kenya and Tanzania. Tanzania has around 8, and Kenya has 6 of them. And in further slightly to the west, you have also in Rwanda and also in Burundi, and also in the eastern part, you have in Somalia, and also slightly north is in Djibouti and the Seychelles. That's their current deployment in Eastern Africa. Mm. In Southern Africa, the bulk of the root servers are in South Africa, and you have around 24 of them in South Africa. Then you also have in Mozambique, you have in Namibia, in Zimbabwe, Madagascar, and Mauritius. And also in Southern Africa, I forgot to mention, you have 6 root servers that are in Angola alone. So that is an overview of how the root servers have been distributed in the continent. It's 16 hours. Sorry, that was my clock announcing. So, all right then. So I'm sorry, I think that label is incorrect, but the second question is which root service instances are deployed in your country? This is the second quiz. I would like you to go to www.menti.com. Please don't enter that code. Enter the one that has been shared by Willie on the chat, and I await your responses. Thank you.
So head over to menti.com and use the code 7341713. Which root server instances are deployed in your country? Is it A, B, C, up to L, up to M? Is it none, or do you have no idea on what is deployed? So Paul just mentioned some of them in his previous slides. So if your country was mentioned, maybe you have an idea of what has been deployed.
Okay. And if you have no idea, you can go to the link I've just shared. It's https root-servers.org, and you can actually zoom in. You'll get a good map of of their distribution in the continent, and you can check for yourself.
So will you post the link in the chat? So in case someone wants to check which instances are deployed in their country. So far so good. Most of us, no idea. We should see no idea going down. In case you're checking the instances available, at least you should have none or A up to M. So Paul, as the others are filling it in, so any comments as we move on based on the
Yeah.
results?
So I got a question is, what if they are multiple? Okay, maybe perhaps Willie, you may suggest if there's multiple, perhaps you could enter one if you are not given the choice of entering more than one. Okay. So at least we have four have mentioned. Okay, we have one has mentioned the A root, A label. Four have mentioned D. Two have mentioned the E label so far. One has mentioned the I root. Two have mentioned the L root. Four have none, and 13 have no idea. Okay, so we'll come and talk about those who have mentioned none, and Bob is going to talk about the process on how maybe root server can be hosted in a given country. Most of the root servers are actually deployed at internet exchange points, or even at sometimes at ISPs. So what my colleague will do is to give you the process of going on what you should do and how to actually host one of the instances, and he'll guide you through that. So is it okay I proceed?
Yes, Paul, proceed.
Okay, sure. Okay. So I'm going to talk about within the ICANN community, which constituency is actually specifically geared to discussing and managing issues concerning the root server system. I should mention that within ICANN, the root server, because it performs a very critical role, you'll find that there, besides the root server system advisory committee, which I'll discuss briefly, there are other parties and stakeholders who are interested and contribute towards the overall management of the root server system, even if they're outside within the ICANN community, or even outside, or even they're external to ICANN. Okay, so the root server advisory system advisory committee provides the ICANN board and community opinion. It provides advice. It does not make policy. It advises the ICANN board on the security, integrity, and the operation administration of the root server system. So currently, the RSAC consists of only 12 root server operators, the operators who manage each of the 13 labels or server identities that I mentioned. All of them are represented in ISAC. However, at the same time in RSAC, you have what you call liaisons. These are now parties that are external to the root server operators that actually work hand in hand with the RSAC in order to ensure that the integrity and the security, the resiliency of the root server system as a whole is actually managed, and it's technically robust. So these organizations, or can I say, include the IANA functions under the PTI, which is basically part of ICANN. So PTI actually, as I showed earlier on, it works hand in hand with the root zone maintainer, VeriSign, to publish the root zone and to distribute it now to the root server operators who then publish it on the root servers. And because of that, they are actually very important stakeholders to RSAC. The other one is now the IETF, the Internet Engineering Task Force, which is represented by the Internet Architecture Board. So the IAB, you could say, is oversees the activities of the IETF. And they also, because they maintain technical standards and protocols, they are represented on, they are part of the liaisons within the RSAC. And the last one is different ICANN's constituency within the ICANN community known as the Security and Stability Advisory Committee. So in ICANN, there are actually 3 advisory committees. The RSAC is one, the SAC is the other one, and the last one is the GAC, which is the Government Advisory Committee. So I mentioned GAC, where governments are represented in ICANN. So SAC is now technical, can I say experts? It's made up completely of technical experts who are very proficient in the security, especially of DNS, on cybersecurity, and any issue that will affect the domain name ecosystem and the identifiers. So they too have also a stake in the RSAC as liaisons. But I'd like to mention something that as of this happened around 2015, the RSAC opened up its activities to DNS experts from across the globe. And it formed a group within the RSAC known as the RSAC Caucus. So the RSAC Caucus is actually composed of DNS experts from across the globe. As of March 2027, there are 7 experts or caucus members from the continent. I'm happy to be one of them. And my colleague also, Yazid, also joined the RSAC earlier this year. And so the RSAC caucus basically helps the RSAC, the root server operators, go through documents, look at issues that are important or that affect the root server system as a whole. And then we help actually formulate documents and share them to the board, share them with the RSOs, who then present maybe those documents in the form of advice to the ICANN board. So our work is actually to help the RSOs and the RSAC as a whole to actually document and also investigate matters that affect the overall root server system. Okay, so this will it's a very interesting question that I'd like to ask you. Do you think, how does Africa contribute to the management of the root server system? It'd be interesting to see your responses. So once again, kindly go to www.menti.com, type in the code, and let's see your responses.
So can you type the question in the chat section? Your answers in the chat section. So again, the question, Paul, was, can you repeat the question? And then we can just have a discussion on that. So the question is, does Africa contribute to the management of the root server system? I guess this should be a very straightforward question. Uh, yes, no, I don't know. Yeah, so most of us answered yes, and two of us answered I don't know. So, Paul, based on the results, what can you?
Okay, I'm happy that at least yes, that a majority have actually indicated that it is yes. Yes, it's true. We do actually contribute to the management of the root server system in various ways. Whether it is actually hosting an instance, we are actually yes, participants in the continent are actually helping to actually maintain the overall resiliency of the root server system as a whole, whether it is hosting an instance, whether it is taking part even in ICANN, even if it is not in the RSAC or in the SSAC, or perhaps maybe in none of the advisory committees, but even the essential role by actually in the policy development process, by actually taking part in that, one way or another, you'll still affect the root server system because all your changes to that will go to the root zone or whatever will be published in the root zone comes from the community. And I'm very happy to see that there's quite a very active community from the continent in ICANN that participates in ICANN processes. So other than that, I think I don't have any query except those two who mentioned I don't know. I hope I've been able to clarify how various stakeholders within the continent are contributing to the overall growth and also management of the root server system. Hope that clarifies that. So
Yeah, thank you
let
very
me,
much, Paul. Proceed.
okay, so right. Now, since I mentioned RSAC from 2022, there's actually a proposed new governance model for the root server system. So for the last, let me just make it this way. Let's go to this one here. Since since the 1984 up to the time ICANN was established, the root servers were managed basically by Jonathan Postel. So when Postel died in 1998, there was actually a process that led to the creation of ICANN. At that time, ICANN was actually and signed a memorandum of commitments with the United States government. And it was not until 2014 when now that memorandum of commitments actually came to an end, and the global internet community was now responsible for managing now and seeing oversight of ICANN. But the root server system pre-existed ICANN, and before then, there were no processes to add or replace root server operators. And this has been the case even still today until the new governance model that was proposed actually 2 years that was proposed in 2017. So the RSAC published a document known as RSAC Advisory number 37, which now discusses and talks about the proposed governance model for the DNS root server system. One very interesting thing to note is that this document was okay, before I talk about it, was actually published, but after it was published by the RSAC and it was actually delivered to the ICANN board, ICANN interpreted this document and called out for a public comments period. And that was in ICANN 65 in Morocco. During that time is when the public comments period opened, and stakeholders from different ICANN constituencies gave their input on the proposed governance model and what they wanted to see. So, but in brief, the the RSAC 37 mentions that there are going to be 5 new structures that will come with management of root servers. Let's just call it the root server system. And this will be actually a governance model within the ICANN body as a, or can I say community as a whole. So it'll be a secretarial function, which will deal with administrative work and travel and all of that. And also, of course, setting up maybe a schedule. Then there'll be the strategy, architecture, and policy function. Now, this is actually going to be the concerned with actually the technical and the architectural aspects of the root server, whether they meet maybe certain standards of quality of service. And then in this one here, there'll also be the policy function. So there'll be policies that will be made to discuss the architecture and overall strategy of the entire root server system, whether there should be more instances, whether there should be another label, because the DNS protocol has changed and it can allow currently more than 13 labels. So this will be actually the function that will discuss this and implement it. Then there'll be a designation and removal function. So this one here is going to actually do the following task. It will say, okay, fine, you've not been able to meet this service level agreement that was meant for the community. So in this case here, perhaps an RSO can be stripped of its label and it's designated and given to a different, maybe root server operator. There's also the performance monitoring and measurement function. This is entirely to collect matrices and measurements of the root server system, how it's performing and whether it's actually meeting the given thresholds. And it is through this function that that a decision could be made by the designation and removal function on whether a given maybe label or server or a root server operator is actually meeting certain thresholds. Finally, there's a financial function that will deal with budgeting and finances. So I would like to mention this is not been implemented yet. This is a proposal or a proposition. It is still being discussed. And as I mentioned, the ICANN board published a concept paper that interpreted what the RSAC 037 is. And it envisions that it's going to continue, that there'll be a new cooperation and governance model for the root server system. And it also outlines 3 phases on which the wider ICANN community can actually be part or co-opted into cooperation between, can be actually be co-opted in this governance model, the RSS. So the concept paper is published on the ICANN website, and also the RSAC 37 paper is also published. You can check out this document, the source here. Oh, sorry about that. ICANN.org groups RSAC documents and search for RSAC advisory 037. You'll be able to get the document. Okay. So without much ado, I have given the overall history and also where we are now and what is being proposed in the future. So I would like to call upon my colleague Bobo Cheng to actually talk about how you can actually host a root server system, in particular an ICANN managed root server, IMRS, which is also known as the L label. Okay, so welcome, Bob.
Thank you very much, Paul, and for that quite a detailed run and background on the root server system so far. I hope my audio is clear. So mine will be very brief, and I'll just take you through quickly how exactly, and zeroing in on one of the labels as has been discussed by Paul, that ICANN manages, that we call the ICANN managed root server, formerly the L root. And this is because we understand and we have gotten queries on, what one needs to do, why should you host an instance, how do you go about it, who can, make the request or who can host it. So the next few slides will give us kind of an insight on how ICANN deals or manages its own label, the L root or the ICANN managed root server. So first of all, one of the key reasons why you might want to have a root server instance either in your network or in your country, depending on where you sit, if you're a policymaker, or if you run a network, is for a couple of reasons. One is to ensure that you have a secure and more stable and resilient DNS infrastructure very close to you. Secondly, it reduces the response times to users' DNS queries within your network or within your borders. So as you know, DNS queries, the first DNS query would always go to the root server, and that would be the nearest root server instance. So the further it is from your network or from your country or from your user, the longer the response time. And lastly, to reduce internet bandwidth usage taken by DNS queries. So if that query can be answered locally by the availability of an instance locally, then the net effect is a reduction on the overall international traffic, that is DNS queries, that does not really have to go beyond your networks or your borders. Next slide, please. Okay. The next question is where or who can host an instance? Here we are using different terminologies, but I want us to understand it as the same thing. An instance, a root server, because Paul has talked about the 13 root servers, and we are talking about instances spread around the world using Anycast technology. It is one and the same thing. Remember, in one of the initial slides when Paul discussed the distribution of the root zone. So the root servers serve the root zone, meaning that the response you get from any root server is details of the root zone, and they have the same information. So whether you talk of an instance or the 13 root servers, you're talking about the same thing. They have the same information. Whether you get a response from A, from B, or from L, you get the same response because they have the same information. So that is very critical. Now, as has been indicated, most of the operators or the 12 operators of the labels have different structures or policies around their specific labels that they operate. So ICANN, as an operator of the ICANN managed root server or the label L, has own policies on how and on who and where that particular server instance can be hosted. As Paul had indicated, some servers or some operators prefer, or in their rollout structure, their instances are placed in IXPs or Internet Exchange Points. Others don't do that, and ICANN is one of them. But it is important to note that for the ICANN managed root server specifically, while it is not placed in an Internet Exchange Point, the host is required to peer with neighbors or to run BGP sessions so that other providers and other users can benefit from that particular resource. So basically, if you are hosting the L root or the ICANN managed root server as, let's say, network operator X, the expectation is you will share that particular resource with other network operators around you so that they benefit from that particular resource. But it is not there. The server itself does not peer in an Internet Exchange Point. That is as per ICANN policy. But we have other operators whose policies are to ensure that their particular servers appearing in internet exchange points. So I'm just trying to highlight that the rollout strategy or the policies around where those particular servers are placed differ from, operator to operator, or from a label operator to the next. That is important to note. Next slide. Okay, so I think I already talked about this. So each server operator independently defines its own strategies for deploying and operationalizing the instances. I think we already talked about that and highlighted that for ICANN, while the root server itself does not or is not placed in an internet exchange point, it is preferable that the host of that server is a member of an internet exchange point so that the rest of the community can also benefit from that particular resource. Next, please. And so on this particular slide, I'll tell you a little bit more on the process of going about getting the ICANN managed root server for those who are interested in hosting one. First of all, you need to get hold of the nearest ICANN contact, global stakeholder engagement team. Could be myself. You could reach out to Paul, you could reach out to Pierre, Yao-V, or any member of the staff in Africa. Will guide you accordingly. But basically what you need is just the server hardware to host the particular instance. And currently we have two options. Option one, which is the 1U, and option two, which is a Pandora box, 10 gig. The difference is in their capacities and depends on how large your network or your users are, and so the cost of those particular servers. But it is restricted to these two hardwares, and this is because of the kind of centralized management for this particular server system. So we don't accept any other kind of hardware infrastructure. Anybody who wishes to host is expected to acquire either of these particular server instances hardware for us to proceed with the installation. Now, if you can confirm that you are able to get the hardware requirement, we'll link you appropriately with where to with the supplier and have the server installed and pre-configured so that it comes to you largely as a plug and play box. Remember, your responsibility as a host would basically be to ensure that that server is online and is available 24 hours. But the exclusive management or access is solely by ICANN as the operator of that server. Remember, root servers are critical infrastructure and they're exclusively administered by the respective managers. So while it could sit in your network, you literally don't have access or cannot access it because the operator takes responsibility on the security and stability of that particular network as a whole. That is why its access is exclusive only to the operator. And for the ICANN managed root server, it's exclusive to ICANN. We have additional information should you have other questions detailed on this particular frequently asked questions site that we have listed there. So just to summarize your responsibilities, if you feel that you need or you are interested in hosting the ICANN managed root instance, please reach out to us as the first step. So you need to reach out or to volunteer that I'm ready to host this particular server. And two, confirm that you can be able to afford or to access or to buy the required hardware. In cases where you are not able to get the hardware, we do have an arrangement, memorandum of understanding with AFRINIC, but it depends on a case-by-case basis, including on AFRINIC's budget and other conditions. For AFRINIC to support you with the hardware, and I'm sure Cedric will talk a little bit more about this, but I'm just saying that it is possible to get support to acquire the hardware if you are not able to afford one. Next slide. So the other thing is, if it is a server that is not managed by ICANN, what we could do is to point you to the relevant manager of that particular server. And like we said, each of those servers have, or each of those operators have got their own rules. So what F requires, or what I operator requires, or J operator requires is defined by them. So we are able to point you to them if those are the particular instances that you need, or that works in your arrangement. For example, if you are an IXP, the L route might not be the best solution for your circumstances. It could be a different kind of server. So we'll point you accordingly. Next, please. So I think time for another question, because that would be my last slide around this. And of course, happy to take questions at the tail end. Back to you, Paul.
Okay, so our final question for the webinar is, would you be interested in hosting a root server instance in your region or country? So, as before, kindly go to www.menti.com and type in the code, and I hope to see your responses.
So the question is, would you be interested in hosting a root server instance in your country or region? So this should be based on what Bob has just talked about, what Paul has talked about. Will you be interested? We just like to know. Will you be interested in hosting a root server instance in your region or country? So yes, we have positive results over here. So ignore the X's, right? So most of us say that they're interested in hosting a root server instance in their regions or countries. Paul, any comments on that?
Okay, so it'd be good to know if perhaps those who answered no, whether maybe on their justification, but yes, it's highly commendable if you would like to actually host a root server instance. It's just an infrastructure that will help actually enable and improve on the resiliency of DNS, and overall improve also the internet, let's call it, say, quality of service within a region, because one of the advantages of hosting an L route is that rather than sending your queries outside your country or region, or even sometimes city, depends on how big your country is, you'll actually have that all the queries that are associated with the route will then go to the nearest instance, and if it's within your country, then it'll just be resolved within your country. It doesn't have to leave your networks to go maybe to a far off country for resolutions on the root zone. So actually, I would encourage for those who will be seeking or will be interested to actually host one. Okay, so I think I can then introduce our next speaker. Okay, give me
Paul, I see a question from Richard as you do that. on why the L root is not is not the best for an IXP. So I'll just reiterate that it is not that it's not the best. It is just a policy taken by ICANN that that particular root instance is not deployed to peer. What happens in an internet exchange point is peering networks, but the root server itself, the L root in this particular case, does not peer. Now, any host who is peering in an IXP is welcome to host the root server and share its resources by the peers. So in other words, it is the way it is deployed that is a little bit different. It doesn't peer directly, but by all means, it will be able to sit on a network that is peering or networks that are peering in a particular internet exchange point. So I hope that makes sense. Back to you, Paul.
Okay, and I think there's also a question directed to you, Bob, from an anonymous attendee. The question is, what are the cost implications of hosting an instance from hardware purchase to config and maintenance?
So the cost is on the hardware only. The server is configured by ICANN and it's solely accessed and managed by ICANN. So once you buy the server hardware, of course, there's a cost in maintaining it on power, making sure that it is online. But in terms of configuration and actual management and access is solely by the root server manager, in this case, ICANN. The first option, the Calypso, is roughly $2,000 or thereabout to acquire the server. So I think that's the major cost if you're buying the server.
Okay. Sarah, you have a question on why ICANN cannot help by providing equipment and build infrastructure. My colleague Cedric is going to actually explain AFRINIC's role in this, because we do partner with AFRINIC in actually providing hardware. He's going to give an overview of how AFRINIC is able to assist in the process of acquiring and hosting a root server instance. So I think we'll call upon Cedric to give his presentation and also to answer some of the questions that have been mentioned. Welcome, Cedric.
Good afternoon, everyone, and thank you, Paul and Bob, for the presentation. This is Cedric here, IT Infrastructure Unit Manager from AFRINIC, and I am here to talk about what we call the AFRICP, which is the Africa Root Server Copy Program. So this is a program that AFRINIC started years ago, and to target principally IXP, but not exclusively. The question will be why IXPs only, why mainly IXPs? This is simply because at that time, most of the IXPs in Africa were voluntary based. So it was initiative from the community to build an IXP, and most of the time there were not enough funds to maintain the IXP. So that's the reason why the program target principally the IXPs. But knowing also our region of service, which is Africa, IXPs are not always present in all the countries. So reason why we also work with other people. And the main objective is to increase the number of nodes in our region, so Africa, and we do so by supporting the purchase of hardware and also facilitating all the admin and contact part. So as Bob mentioned previously, there is a cost of maintaining an instance of a root server. So mainly there will be the cost of purchasing the hardware. So as Bob said, for the Calypso, it's cost around $2,000. Then you also have to add the cost of the shipment and everything else. And also when you actually request to host an instance, something that will be required from you is to ensure that the instance remain powered on 24/7 to ensure that everybody can access it. And the ultimate goal, again, is to ensure that we increase the DNS resilience in Africa. As you can see by going on root-servers.org, you will see that not all the countries have DNS root nodes, which is really sad. And we really hope that more people will actually apply to get to host the instances. And if you want for more information, you can go to the link below. I will also put it in the chat. And then you will go through a form to apply. And what we do at AFRINIC, we usually support around 5 deployment per year. So that's the max that our budget can support for now. But depending on how things will go and if the program is very successful, we can also see how we can increase the number of nodes that we deploy per year. We at AFRINIC work mainly with ICANN, but we are also working with other root server operators. As it was said before, ICANN right now target uh, other operators than IXPs. So for IXPs that are interested into the program, we'll see with them which operator is the most appropriate for them. So thank you again, and back to you, Paul.
So thank you so much, Cedric, for your presentation. I will just want to conclude the webinar by just mentioning just in a summary form of what the presentation is. Okay, just quickly, I'll summarize. So basically, currently, the root server system today, it does enjoy a strong, robust, and very highly redundant infrastructure. And it has withstood the test of time since its origins in 1984. By and large, the African continent does need better root service coverage. I will mention this. Yesterday, I mean, 2 days ago, Bob and I were presenting to SADC, the South Africa Development Community, and all the members of SADC, except 3 countries, do not have a root service system. And so there's still some gaps, and there are still places that do need the services of the root or the service of the root zone, and hence the root server systems. So there's still some room to grow in the continent, and quite a lot for actually more deployments. And as the internet continues to evolve, both in terms of technologies and usage, the root service will become even more and more critical. This is in line with upcoming trends, including Internet of Things, where we'll have billions and billions of devices. And many of these devices will still rely on connecting through to reaching services via DNS. With that, they'll need actually access to more robust and even low latency root server instance. And also with the growth of even 5G and more phones. So the purpose and even the root server system has even become more essential. And finally, I'd like to just mention that we talked about the new governance model. Could be a very valuable and significant contribution to the evolution of the root server system, because as members of the ICANN community, even if you're not directly involved in in the RSAC or any of the liaisons, you'll be able to actually get reports and even monitor the performance of the root server system as a whole, and even maybe seek out changes that will be of importance to the community. So those are just my concluding points in a nutshell. And with that, I just want to mention one more thing. For those of you who like to know more, you can reach us out at ICANN. You can visit our website at icann.org, or any of our social media pages on Twitter, Facebook, YouTube, Flickr, and so on. So thank you so much. I also want to thank AFRINIC for actually hosting this presentation, and also working with us to actually come up with a presentation. And thank you so much also for your participation. And I'd like to hand over the session back to Bashir. Thank you.
Thank you, Paul. Before we complete, I can see some questions, 3 questions pending in the Q&A. Maybe we can just address them quickly, if think we have time. So the first one is Cedric, you pointed out that what was noticeable in the root server instances Paul presented, scattered instances with some countries. 6 in Kenya, 8 in TZ, UG having none. What could be the cause of this? Could there be lack of awareness? Cedric, answer to that.
Thank you, Bashir. So usually, I will say yes and no. There is part of the reason why you will see instances scattered like that is because there's a lack of awareness. But also it's related to the infrastructure that are locally in place. In countries like Kenya and Tanzania, you have IXP in place, and sometimes those IXPs will operate from different data center. So they will ensure that in each location where they operate, they have they have an instance of the DNS root server, a copy of the DNS root server. And now for countries where there is none, it can be for different reasons. Sometimes it can be political reasons. Sometimes it can be lack of someone being available to host and also we at AFRINIC, we have, as I mentioned, we have a program to support, but we won't force anybody to do so. We'll encourage people, but we are also waiting for someone to come and request for it, so we can support and hand over the equipment there. If you allow me, Bashir, there was a question, also, sorry, a comment from ITAM from Egypt. And he said that I answer no, because we will volunteer to pay for the required internet bandwidth for the periodical zone updates. I just wanted to come to this because that's the question that most of the time people ask, who is going to pay for that? The good thing is that for DNS, the requests are very small. So it's not a lot of traffic that will be generated by the nodes. So which is okay, but still there is a cost, which is electricity and obviously internet connection. So yes, you need to find someone who is willing to ensure that the node is powered on 24/7 and there is good internet connection to do the update of the zone. Thank you, Bashir.
Thank you, Cedric. I believe the last question, the significance of hosting, we've answered that throughout this session, unless I'm wrong. Paul?
Okay, the question is, what's the significance of hosting? Okay, so what would happen if you do host a root server instance, doesn't matter the label, is it will actually help speed up the processing of DNS queries that are sent from various ISPs. And this actually helps improve generally the performance and also the quality of internet experience that users will have, because with faster resolution DNS queries, that means basically you end users are able to actually access even content slightly much faster than if maybe the root servers were perhaps in a different location outside your country. So hosting actually helps in overall improvement of of actually the DNS and also of better query resolution. Of course, there are other things that will need to be considered, because the DNS is not just the only critical internet infrastructure. The presence of IXPs, internet exchange points, also helps improve internet experience drastically. So I will not just only say it's the root zone, the root servers, but it is also various infrastructure and also certain practices like having content distribution networks. Of course, this is quite an investment for maybe maybe an ISP or even a network operator, but having this core infrastructure located and managed optimally within your country can help improve the overall internet experience within that region. I hope that answers. Then also you had mentioned something, how can you participate and have a mentor and grow in the space? So I just wanted to mention that if you want to join the RSAC caucus, I will leave the email below in the chat. You can actually send it, but I'd like you to understand that basically the RSAC is going to, you'll have to send a statement of purpose, of interest, where you'll maybe indicate why you want to take part in the caucus. Perhaps you want to contribute to your DNS expertise. You understand basically DNS and the root. They'll ask for that, and you can also give your CV. And once you sent those details, then they will approve you of your membership. They'll announce it to the entire RSAC mailing list. And then you're just part of the caucus, and then you can join any work party within the RSAC. So work parties are now the groups that deal with different issues concerning maybe the root server system. So I'll just leave you the email address for joining. I've just pasted it in the chat. So that's just one way you can join. But if you don't need, if you don't want to join the RSAC, the other communities within ICANN that you can join and still take part in discussions concerning the root. Okay, and yes, Lawrence, I do agree with you. The value to Africa is immense of hosting a root server system. And yes, we look forward to you hosting an LRoot node in the region. Okay, that's about it from me.
Thank you, Paul. I believe all the links will be shared. The slides have all the relevant links in case you want to get assistance from AFRINIC, in case you want to get in touch with ICANN. So all the links will be shared in the slides later on today, and the recording will also be shared. So I thank everyone for joining us today, and see you in the next session. Thank you, and good evening, good afternoon.